Hello, everyone. Good afternoon, or good evening, or good morning, wherever you may happen to be. Maybe I should just go with good day. Hello, Sabin. Hello, Rakesh. Hello, Francis. Hello, Danielle. Hello, Emmanuel. Hello, Hannibal. Hello, Tolu Walona. Hello, Alamgir. Hello, Alka. What do we have? Sorry, Nepal, India, Mexico, Cameroon, Tunisia, Bangladesh, a wide variety of locations. Hello, everyone. Hello, a lot of Pupo. Hello, Collins. Hello, Helena. Hello, Yanis. Yes, Yanis from Greece. Can't forget Yanis from Greece. Hello, Teddy. What do you all want to discuss today? I've tried to answer various questions or added comments to things that were popping up on the message board. Hello, Sanchit from India. India is not a country that I've yet traveled to. Hope to do so at some point. Mexico I've been to a few times and it's a very nice place. Hello, Zainab from Pakistan. One of my good friends is from Mexico. So yeah, the VC mini project. So, we were talking yesterday about classes in Python. Right? Building your own class can be a very complicated thing to do. There's lots of special methods that can be defined. Is there a simple introduction to object-oriented programming? Well, hopefully this kind of introduction here was somewhat simple. I can see if I could come up with some other references and post them on the chat channels. Do I have any notes to make? Any post-its to make notes to myself here? Looks like I don't. Let me see, how can I make a note to myself? Where did my pad go? Everything's lost. Let's see here. Apologies. OOP references to post on message board. But yes, certainly understanding objects is important, partly because everything in Python is an object. Even down to the simple int or integer, right? This is actually implemented as a Python object. And so, right, we've, as classes, right, there's objects, classes. Generally, I use these words interchangeably, which is probably poor on my part. Generally, the terminology, as I've heard it, is that the class is kind of the structure, the skeleton, the outline, the definition and an object is, an instance of a class. So in this OOP notebook, right, we're talking about rationals as a class. And in this VC mini project, yes, the idea is that we want to work on building our own class. So as it says here, we want to develop familiarity with Python's class syntax and object-oriented programming. So we want to develop a point class capable of handling some simple kind of operations, and we're only going to restrict ourselves to 2 dimensions. Yeah, I think we're going to begin at the beginning here and make sure that everyone is understanding all these things, because I have some more discussion to add along the way here about, say, how we might make our object a bit more richer than what is solely suggested in these exercises. So yeah, every class, there's a huge number of methods that we could define which have special meanings. Let me copy and paste this link here into the chat. This is the link to the web page, which is currently on my screen. It's probably a bit hard to read because there's lots of text, and the text is kind of small. I mean, I can make it a bit, sorry, let me select this. I can make it a bit larger, but then, well, we have less to fit on the screen. But, there's, as I said, there's a large number of methods that we can implement if they're appropriate to define an object. And a lot of these methods are kind of helper methods, right? If I want to be able to add instances of objects, right? If I have integers, right? If I want to be able to add integers, well, we basically have to have some meaning to the plus sign. And we know what that meaning is for the plus sign for integers or floating point numbers. For other objects that we might make, well, we could give a definition, if we wanted to do so, what it means to add two of these objects. And the way that we do this is by defining lots of special named methods, these named methods that begin and end with a double underscore. So to go about defining this point class, well, we have a kind of skeleton right here, but we want to fill in this init method, and we want to modify this repr method to return, information about the values that are stored in this class. So as we said here, right, our point class should accept 2 arguments, and we're going to store these variables x and y as attributes of the object. And we're going to represent an instance of this class by a string, right? This is what we want to modify our repr method right here so that we'll get a string back which will include the appropriate values of x and y that we've stored in the object. So as I said yesterday, right, the idea about the init method, so double underscore init double underscore, this is one of these special methods. When we create an instance of our point class, then this init method is called for us automatically. So what we want to do is we want to modify this. As we said, we want to store these parameters for x and y that we will receive when the object is created. We want to store these internally in our class. And how we do this is we will create these attributes in our init method. So remember, this convention in Python is that we're using this variable named self. And so self right here is going to be like a pointer of handle, if you like, to the particular object that we are referring to. And this is how we can add an attribute to our class inside this init method. So I want to save the two values of x and y that we will receive when this class is created. So let me just define the init method. We'll come back and we'll redefine this repr method in a moment. Right? I could, if I've defined the point object, I could create an instance of this just by using the name of the class, point, and some parentheses and two parameters here for x and y. Now the data type here of this variable is of this type point. This class is defined, this point class is defined in this notebook. This point class has these two attributes. It has a value for x, which we can access with this dotted notation, and it has a value for y, so pt1.y. We can access these two attributes of this point using this dotted notation. Right? If I wanted to, I could reassign this value of this attribute. This may not be the best of ideas, but I can reassign the attributes of this object in this fashion. That's possible to do here. It's not advisable, but you can do that. Now, the repr method is what we get if we pass our variable to a print statement. And this repr method right here, if we read this documentation about data classes, we're told, well, the repr method needs to return a string. There are certain things they say, you know, ideally this string can do this, that, the other, etc. Well, you know, but we, the programmers, have the power. We could do whatever we want inside this repr method, but our repr method should return a string. Now what we want to do is we actually want to modify this string, right? I don't want this to always say 0.00. I want it to say point and insert the value for x and insert the value for y. So one way I could do this is to modify this string right here to accept two parameters. And I could use the format statement to insert those parameters into this string. Right, when you learned about strings, well, one thing that you have seen, should have seen, I hope, is there's this format method. And so for as yes, you could certainly use f strings. I agree f strings are easier. We could talk about f strings. You could use f strings. They're certainly possible. We could use this format method. I need to redefine my class because I redefined this repr method. I'm going to redefine my point so that it will have this repr method in it. Let me remove some of these cells. Now if I print out this object, I get the values of x and y inserted into the string right here. So if I made a new instance of this point class, minus 1.2 and 9, let's say, if I print pt2, well, I see the values of x and y get inserted into the string here. Right, and this is one of the uses of the repr method. When a object is passed to a print statement, well, behind the scenes, what the interpreter does for us is that the interpreter basically makes a function call to the repr method of this object. You know, we can, if we want to, we can make a call to this method of this class as well. Right? Nothing stops us from doing this. And I get this string back. So it said when this object gets passed to the print statement, well, the interpreter behind the scenes makes a function call to the repr method and gets this string. And then, well, that is the string that is printed here by the print statement. And yeah, when you start to create your own class, well, these are probably two of the first methods that I would want to define. Right? If my class is going to store some attributes which I want to pass when I create an instance of the class, well, then I definitely need to define an init method. Right? I want to store these parameters as attributes of my object. And the repr method is useful, say, partly as a kind of debugging tool, right? As I'm testing my class, then, it's often useful, well, right, at some point during whatever test I might be writing, right, I want to say, well, print out this object, and make sure that this object is what I think it should be, especially, like, say, if I start to use this object inside of other functions or other methods, right? I want to generate a whole collection of these things. I want to make sure that I'm getting the results that I expect. And so defining this repr method is quite useful, right? Because you could, as I said, you could define whatever you want as long as you return a string from this repr method. So for this first exercise, well, this is basically all we had to do, right? We wanted to define this init method to store these attributes, these parameters here as attributes of the object, and we wanted to define this repr method. Here, before we had point 0, 0, well, no, we wanted to insert the values of the attributes. So, sorry, the first exercise, you have a class object, the result is a string. Well, we get the string when we pass the object to the print statement. This variable, right, the type of this variable pt1 is an instance of our point class. we get the string when we pass this to the print statement. Now, this, the grader right here is basically checking sort of behind the scenes that our methods are, the string method here is returning this collection of strings. We also, in this case, will also get the same result if I pass an instance of this variable to the method str. And this is what we're checking right here. This, in some sense, this is checking, if you like, both things. This is checking that the init method is working, because, right, we're creating all these points. And it's checking that the repr method is working, because this is going to be converting these things to a string. Right, so yeah, so the idea here, what we're checking, again, what the grader is actually giving us here is a list of tuples. So, for example, let's say if I create a tuple, I could create an instance of my point class, so pt3, by unpacking this tuple. Right, this right here is basically unpacking this tuple into its two arguments. And these become the two arguments that are passed to this point initialization. So we have, say, like we're given a list of tuples. Well, we're unpacking each tuple, we're creating a point, an instance of the point class, and then we were getting the string representation of this class. And so the grader's checking here that our init method and our repr methods are working correctly, because we need to store this information and we need to return this kind of formatting in the correct fashion. Now, as Sarfaraz pointed out, we could use a so-called f string. Let me copy and paste. I'm going to comment out this first return. I'm going to change this into an f string. I do this by adding the letter f in front, and then I basically insert these variables where I want them inside the brackets, and I could remove this format statement. Again, I'll redefine my class and I'll redefine this variable. This is still a type. If I print, I get the same result. Right? This is an f string. So the idea of the f string is that the f right here tells Python that this should do some variable interpolation. Right? The brackets right here are telling the Python interpreter, hey, there's something inside the brackets right here that I want you to interpolate. This is a variable. Find the value of that variable and insert it right here. Find the value of this variable and insert it right here. And this gives us the same kind of result that we were getting before, right? So again, using the format statement is one way to do this. Using this f string right here is another equivalent way of doing it. And actually f strings are supposed to be a little bit quicker than using the format statement. I think f strings are easier to read as well. Right? This method right here, I have to say, oh, this self right here is going to be inserted into this first set of brackets. the self.y is going to be inserted into the second set of brackets, whereas, well, if I read the f string, I know exactly what's going to be substituted where. I don't have to sort of map something back into the string. But either way will work. They will give you equivalent results. F strings, I would probably say, are kind of the future of Python, right? F strings were a more recent addition to the Python language. But, I could probably see them maybe at some point, maybe not deprecating, but, the use of format is probably going to decrease. Right, but here, this is our first, our first kind of definition of this point object, right? We want to add more functionality, right? I want to be able to define these point classes. We're going to see in the next, question, right? I want to be able to define these point classes, and I want to be able to use them, say, in some arithmetic operations. I want to be able to write down this kind of expression, 0.1 plus 0.2. Right? I want to be able to write this and have the Python interpreter know what I mean. I want it to do the right thing. At the moment, well, it says this is an unsupported operand for this plus symbol between 2 points. Yeah, and that's because we haven't given a definition to our class so that the interpreter can understand what this plus symbol means. So as I said, I completely agree. I prefer F strings. They're, they're a bit less to write, they're easier to read, and so on. So when I'm writing code these days, well, I tend to write F strings just because they're a little bit shorter, they're easier to read and understand, and so on. They're easier for other people to read and understand. But yeah, in question 2, right? Question 2, as we said, we want to give some definition to the plus operation. Right? We want to be able to add or subtract 2 points. Well, and the definition, right, is the one we get from mathematics, right? I want to add 2 points. Well, what do? I add their first components. I'll add x1 and x2, and this will give me the result, the first component. I add y1 and add y2 and y1 and y2. Well, we can't add 2 points to one another yet because Python doesn't know how to make sense of it. Right? This plus symbol right here says to Python, right, look in the class definition for a point. And it's looking for a definition, a method definition, which it will give some meaning to this plus operation. So, Python doesn't know how to do it because we haven't told Python what this should mean for point objects. We have to give a definition inside this class right here for Python to know how to interpret this. At the moment it's saying, yeah, this is an unsupported operand for a point and another point. And again, this is part of this big, long data model page. For example, if we scroll down here, let's get to the part that we're interested in terms of numeric kinds of operations. keep going, keep going, keep going, keep going, keep going. I might have passed it by. Here we go. If I want my object to be of a kind of numeric type, right? I want to be able to like add two instances of this class, subtract one from another, etc. As I said, right, there are methods that we have to define. There's a double underscore add double underscore method and a double underscore sub double underscore method and a mul and a true div, etc., etc. We could, if we want to, we could give definitions to all of these methods here for our class. The idea is, well, for the add method, as I said, these methods are called to implement the binary arithmetic operations, i.e. plus and minus and multiply and divide and kind of the double division symbol and so on. Right? So, as this explanation says here, right, for instance, to evaluate the expression x plus y, where x is an instance of a class that has an add method, what happens is that Python translates x plus y into a call to this method, x dot double underscore add double underscore y. Right, so the plus symbol, again, this is a lot of things that Python is doing behind the scenes for us. Right, x plus y gets translated into this function call. And this, so defining something for this add method right here is how we could tell Python how to interpret x plus y for our class. And we can give a definition, say, we'll see in a minute, we could give a definition, how do we add 2 points? We could, if we want to, give a definition for how do we add if x is a point and y is a number. How might we give a definition to that? Or if x is a number and y is a point. Well, to do that, we might need to look at some other methods as well. Right, but so if we want to, again, if we want to define how Python should interpret a plus symbol, we have to give a definition to these add and sub methods. Let me copy my, let me copy this definition right here. So, because I'm going to copy this, I want to add to it, because I'm going to redefine my class. You have to define all the operands methods for our classes in the same class, yes. So if I want to, I can add an add method, which will take two parameters, right? Self, and usually I use this word other, choose whatever name you want here. Now, I'm going to add something here. So let's suppose that I want to give a definition to how do we add 2 points? Well, what are we going to do? I could write this all as kind of one line of code. Well, let's spell things out. A little bit. What am I going to do? I want to make a new point. a new instance of this class. What am I going to do? Well, I'm going to take the x component of each of these 2 points. And I'm going to add them together, and that's my first component in my new point. And I'm going to take the y component in these 2 points and add them together, and that's the second component in my new point. And then I'm going to return this from this function. Right, so again, I'm going to take the x component from the first point, the x component from the second point, and sum them together. And that'll be my new component, my new first component. I'm going to take the y component from the first one, the y component from the second one, sum them together, and that's going to be my second component in this new point. So I'm going to create a new instance of this point class, and that's what I'm going to return from this add method. So again, let me define my function. Let me now, somewhat annoyingly, I have to redefine my points because, well, I've redefined my function. I redefined my class. So I have to redefine my variables. My instance point. Let's put point. The self.x, yes. Yeah, the idea is that x, the components of this point we're thinking of as numeric types. Ints or floats. I could actually put complex numbers in there as well, but I'm just going to use ints and floats in my example. So I could define 2 instances of this class again. Now, because I've given a definition to this add method, now Python knows what to do. All right, what has it done? Well, it added 12 and minus 2 to get 10. It added 10 and 3.5 to get 13.5, and it created a new instance of this point. Of course, I could save this, I could easily save this to another variable. And if I print out this new variable, right, well, I have that result. All right, so as I said, let me write this in a comment. This is equivalent to the following method call. I mean, I'm looking at the right-hand side here, not this is equivalent to pt1 dot _add _pt2. So this expression here, pt1 plus pt2, is equivalent to this method call. And once again, behind the scenes, this is what Python is actually translating. Python sees this. The Python interpreter sees this highlighted portion here. The Python translator, the Python interpreter translates that to this highlighted portion here. It does this behind the scenes for us. And this will evaluate this method call, right? So it would evaluate this method call and return this new point. And we could see this, right? We could do this ourselves. pt1 dot double underscore add pt, let me not forget the other double underscore pt2. We can make the function call ourselves. And we get the exact same result, right? 12 plus minus 2 is 10. 10 plus 3.5 is 13.5. Of course, writing this, pt1 plus pt2, is a lot easier than writing this. And that's kind of the point. As we said, once I define an add method, the Python interpreter will look. In particular, I'll point this out and we'll see what we might do, later on for other operations, right? Python looks at the data type of the first element in this sum. Right, this is an instance of this point class. Python says, what is the type of this first variable in this binary operation? It says, oh, this is of type point. It looks in the point class and says, does point class define an add method? If it does, well, then it makes this function call. If this add method isn't defined in this class, it will look at the second argument. And it will say, well, does this class, it doesn't say does this class implement an add method. It's does this class here implement an add method. That's the letter R add. So if this first class doesn't implement an add method, Python will look at this variable here and say, does that class implement an add? R for like write, the right element. And if this class here, so if no add method here, but yes, there is an add method, well, Python will use the add method of this second variable here. If there's no add method implemented here, no add implemented here, then you're basically going to get a unsupported operation. Said, how do you decide which methods change the objects they're called on and which don't? By returning a new point instead of changing it. Well, right, normally when I add two things, I don't want to change the first element when I'm adding something, right? It's the same way if I'm adding two numbers. 23 plus 45, I'm not really changing the first number, I'm getting a new result. Right? If I set these as variables, x is 23 and y is 45, and I compute x plus y, I get 68, but I haven't changed the variable x, right? I haven't changed the value of the variable x. I'm creating a new result. So, think about, right, if we think in terms of variables, this addition of numbers doesn't change the first variable or the second variable. I get a new result. And so it's basically the same kind of behavior right here, right? I don't want to modify either one of these 2 points in this addition method. I want to create a new point. So this is why we create and return a new point. I could, of course, make this a bit shorter. I could just put this return statement here. I could say return this new point. Right? I don't have to create it, save it in a new variable, and then return that variable. Well, I could just return this, and this will work exactly the same way. pt3. Right? I have an add method. I could define a sub-method in a similar fashion. Right? Let me copy and paste because, well, So how can I define a submethod? Well, I will say submethod. What do I want to do? I want to subtract the second point from the first point, right? So I want to take the x value from the first one, the x value from the second one, subtract the second from the first. Take the y value from the second one, subtract from the first. Right, so again, well, if I'm going to have to redefine, I could say print pt1 plus pt2, print pt1 minus pt2. And with an add method, well, Python knows how to add things. With a sub method, well, Python knows how to subtract two things. And of course, if I change the order of the 2 points, well, I'm going to get different results. Right? PT2 minus PT1, well, I get negatives of each other, right? Because, I've changed the order, right? It's like changing the order of two numbers in subtraction, right? 10 minus 2 is 8. Well, 2 minus 10 is minus 8. Right, but again, the minus right here, Python will translate this into a call to the sub method on the object. Now, I'll point out point 10, 1 plus 4. Python doesn't know how to interpret addition if, say, the second argument here is not a point. Right? It says we get an error, right? The int object has no attribute x, right? Because this is an int. This is not an element of the point class. It's an int. It's looking for an attribute of 4, called x. Well, an int doesn't have an attribute called x. If I want to, if me, the programmer, wants to, I could redefine my add method and give a meaning to this kind of addition right here, say when the second element is an int or a float. Right? But this is, again, this is a choice that I, as a programmer, can choose to make or can choose to ignore. If I wanted to change my add method right here to give a meaning to this, well, I have to modify the method above. All right, I could do some checking. I could say if is instance other of type point, we will do the thing, right? I'm going to add 2 points, right? If my second argument is a point, I'm going to create a new point. If my second argument is, say, an int or a float, well, I could define what I want to do right here. How about I return a new point where I add this value self.y plus other. I'm going to add this value to both coordinates. Right? If I have an int or a float, maybe what I will choose to do is I will add this number to both the x and y coordinates. right? Again, I could redefine my add method. I could redefine my points. My addition between points still works as before. Now, because I redefined the add method, well, now I get the result that corresponds to my definition. Right? This is because I chose to define how to add a point and an int, or a point and a float. This will work for a float as well. Right, again, this is because I chose to alter my definition right here and test to see what this other is. Right? Again, this is a choice that we as the programmers could make. This is still going to error, like, if I try to add a string. Well, sorry, it doesn't error. I could add an error. I could say else, because my function right here, if it's not a point or an int or a float, I'm not returning anything. If I have something which is not an int or a float, I might raise a value error. Right, I might say other must be a numeric type or point. So if I have a point, I know to return a point. If I have an int or a float, I do this. If I get something else, I will throw an error, which is what I kind of wanted it to do. But right, if I try to add a point and a string, well, it says I get the error message that I put into my definition. Right, so I could add a float to a point. I'm going to get an error if I reverse them. Right, and as I said, this is where things can get rather complicated, right? Python looks at these two arguments. It says, oh, the first one is a float. Right, this is a float. It looks in the add method of the float class and says, ooh, the float class, the add method of the float class, does it know, is there a definition for adding a float to a point? No. All right. It will look in this class here and it will say, is there an radd method defined in the point class? No. So it will throw this error. What we can do is I could add another method in my class. Yeah, the same for subtracting. Yeah, subtracting a number won't work at the moment. What I could do though is I could add a new method. I will call this radd. And the idea is, well, again, this kind of reverses the arguments, and so this should work if I call this radd, but I don't have to change any other code. My addition of points still works. My addition of a point and a number still works. Now my addition of a number and a point now works. As I said, it's because of how the Python interpreter works. Like, what happens here? So, right, I'm going to write this out. The Python interpreter sees 4.10, and that is a float. Does a float implement a add method to give a meaning to adding a float and a point? Right? This is basically like what's going on. The Python, it will see the 4.12 and says, oh, that's a float. Does a float implement an add method to give a meaning to adding a float and a point? In this case, no. Okay. Does point implement a radd method to give a meaning to adding a point and a float? Yes. So use that method. Right? If you happen two different methods with the same name add will throw an error, it will basically use the second definition that you've made. It will use, whatever the latest definition is. Right? So add and radd right here are basically giving us the same results, but one method, if this kind of expression is used, we're using the add method of the point class. If we see this expression, we're using the radd method of the point class, because the float class has no definition for how to add a float and a point. You have to think before all the kinds of operations or manipulations with the object or a class in order to find all the methods. Yes. Defining a class could be a rather lengthy affair. Right? How do you want to use this class? What kind of operations do you want this class to be able to support? Is it going to be a numeric kind of class where I want to be able to, add and subtract things? Or multiply things, or what have you? Yeah, then you might need to write a lot of code to, essentially implement all those things. Right, I've changed the add method to add a point and an int or a float in either order. I might want to change the sub method to do something similar. Right, I might want to say, well, if is instance other point, well, do what I was doing before. L if is instance other of an int or a float. Well, what do I want to do? I want to return a point, but now I have like a number minus a point. I might say, well, all right, let's take other minus self.x and other minus sorry, I'm looking at a point minus an int or a float. Apologies. Self.x minus other self.y minus other, and then say I will otherwise raise a value error. A numeric type or point. Right, so I take the x coordinate, subtract this number, take the y coordinate, subtract this number, and now I could subtract a number. So I could take a point and subtract a number. What if you want to make an int minus a point? Well, I'm going to need an r sub method. And, with an appropriate definition. So yeah, right. This works. A number minus a point, again, doesn't work. Does float implement a sub method where, this is a point? No, it doesn't. So we'll look here. Does point implement an r sub method? If it is, well, it will use that. So we would have to define an r sub method right here if we wanted to give a meaning to this, where the first argument is an int or a float. But we're out of time for today, and so I'll let you think about that if you want to, and how we might define an r sub method. Of course, later on, well, we're actually at the point where we should be able to pass our grader for question 2. We've defined how to add and subtract when x and y are both points. And we want to, give a definition to multiplication. What do I mean by multiplication, between a number and a point or 2 points? So again, well, I need to add more methods here to my class. So as we said, a class definition could become rather lengthy if I want to implement all sorts of different operations. But I added this else right here because before, if it wasn't a point or an int or a float, our function was returning none. And it would be much better practice to raise an error if the definition doesn't make sense. Right? Adding a point in a string doesn't make sense. So, it's better practice. What I did here is, well, let's raise a value error if the addition method doesn't make sense. Same way for the sub method, right? If I try to subtract a string from a point, well, that makes no sense. So, let's raise an error. So then we kind of cover all cases, right? I get a point, I know what to do. I get an int or a float, I know what to do. I get something else, I will say there is an error. At least warn, the user, oh, this makes no sense. So, we're going to leave things there for today, and we will pick up tomorrow, right? We could, if we want to, define an r sub method, if we want to give a meaning to that. If I wanted to define some meaning for this kind of expression, we could talk about, well, how do we give a definition to a mul method, right, to multiply 2 points? So we'll do that tomorrow. So thanks for the questions. Thanks for your attention. Hopefully, this is making things a little more clear. As I said, classes are useful. They are also complicated if I want to add all sorts of functionality to them. As I said, if I look in this data model, there's a load of possible numeric operations I might consider defining, and there's the corresponding sort of right methods, if this is supplied on the right. So we shall see you tomorrow.